In this video, we're going to talk about the derivatives of the trigonometric functions. We're not going to prove any of these derivatives, but you could do so using the limit definition, some trig identities, and a couple of special limits that I'm going to give you. These are both proved assuming that x is in radians. Okay. So if you wanted the limit as x goes to 0 of sine x divided by x, this limit happens to be equal to 1. Okay, and if you want the limit as x goes to 0 of cosine x minus 1 over x, this one actually goes to 0. These limits are important when you're proving the derivative, using the limit definition to prove the derivative for the trig functions. Okay, so here x is in radians. To try to convince you of the derivatives, at least the sine one, I'm going to use the graph and think about what the derivative will look like. Okay, so here my grid is a little bit funky. Okay, but this is the graph of sine. So sine is 1 at pi by 2, and 0 at pi, and negative 1 at 3 pi by 2. Over here, this is going to be negative pi by 2, negative pi, and negative 3 pi by 2. Okay, so what we want to do to graph the derivative is we're going to think about the tangent line. Okay, so where the easiest spots to find are where the tangent line equals 0. So you want to look for places where the tangent line is going to be horizontal. Okay, because then the slope is going to be 0, which means the derivative will be 0. So at each of these sort of peaks or valleys, the maxes and mins, we get slope of 0. Okay, so that means that the derivative at those points are also 0. So at pi by 2, we're at 0. 3 pi by 2, we're at 0. Negative pi by 2, we're at 0. And negative 3 pi by 2, we're at 0. So this is pi by 2, 3 pi by 2, negative pi by 2, negative 3 pi by 2. Okay, now let's think about where the graph is the steepest. Okay, so it looks like around 0, the tangent line is going to be as steep as it gets. Oops. Eraser. Let me try that again. So the tangent line would look something like this. So if we approximate its slope, it looks like the slope here is around 1. Okay, so that's going to give us a derivative at 0 around 1. Similarly at pi, this is another point where it's fairly steep. Okay, and the slope is going to be similar, but now it's negative. So this slope looks like negative 1. So at pi, we're down at negative 1. Okay, similarly at negative pi, we're also at negative 1. Okay, now if we think about in between these points, so between 0 and pi by 2, for instance, their maximum is 1, and then if you think about the tangent lines anywhere in between, okay, they're positive, but they're getting closer to 0, so they're approaching 0. So that means in our graph, they're going down from 1, and they're approaching the 0 point. Okay, now from negative pi by 2 to 0, okay, so here it's close to 0, and then it's getting closer to 1. So it's increasing and going up to 1. Okay, now if we go between pi by 2 and pi, so once I pass pi by 2, my slopes are close to 0, but now they're negative, right? And they're approaching negative 1. So they're going to come down like that, approach negative 1, and then they're going to come back up towards 0. Okay, and the graph is going to continue like this, so it looks similar on this side. Okay, so this is the graph of the derivative of sine x. Okay, so using the graph. Now what does this graph look like? It looks like the cosine graph. Okay, and it turns out that the derivative of sine is in fact cosine. Okay, so you can do something similar for the graph of cosine. So if you want to take this graph and use the same reasoning, you're going to get something that looks like sine but flipped. Okay, so the derivative for sine of x is actually cos of x, and the derivative of cosine of x is negative sine of x. Okay, now it's important to note that these are in radians. Okay, so because like the proof, it uses those limits that were proved for radians, these derivatives are in radians. If you want x in degrees, you're actually going to get an extra factor of pi over 180. Okay, so this would be pi over 180 times cosine of x, or negative pi over 180 times sine of x. Okay, so you get this extra factor, so we normally compute derivatives in radian mode. Okay, so if you have a degree, you want to switch to radians before you plug it into the derivative. Okay, so you want to switch to radians before plugging in numbers to the derivative. Okay, so then we can use those derivatives instead of these more complicated ones. So let's do a couple of examples. So let's say I want the derivative of 6 sine x minus cosine of pi. Well, the other rules tell me that I can pull out the 6 and then take the derivative of sine x and subtract the derivative of cos of pi. Okay, now cosine of pi, this is a constant. In fact, we know cosine of pi is actually negative 1. Okay, so it's a constant, so that derivative is 0, and the derivative of sine is cosine x. So I'm going to get 6 cosine x minus 0, or 6 cosine x for my derivative here. For the next one, I have two functions multiplied together, okay, that both have x's, so I'm going to use the product rule. So maybe I have my u and my v. You can put the 2 with one of the functions, or you can pull it out completely and bring it in after. It's up to you. I'm going to include it with the sine x. Okay, so then if you want to compute them separately, u, maybe I'll write what they are. Okay, so u is 2 sine x, which means that u prime is going to be 2 cosine x. V is cosine x, which means v prime is going to be negative sine x. So then when we're using the product rule, y prime is going to be u prime times v plus v prime times u. Okay, so that's just using the product rule. Now if I plug these in, this is going to be 2 cosine x times cosine x plus v prime is negative sine x times u, which is 2 sine x. Okay, so we end up getting 2 cosine squared x minus 2 sine squared x. Okay, so that would be our derivative. If you want to factor out the 2, you can. Okay, so that's what our derivative would look like. Now we can actually use only these two derivatives, okay, to find the derivatives of all the other trig functions, because all these trig functions can be written in terms of sine and cosine. So tangent is sine x over cos x. So that means that if I want the derivative of tangent, I can use the quotient rule. So it's the derivative of sine x times cosine x times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, the derivative of sine is cosine times cosine x minus the derivative of cosine is negative sine x times sine x all over cosine squared x. And if I simplify, I have cos squared x. Now I'm going to have plus sine squared x over cos squared x. And if we remember the Pythagorean identity, cos squared x plus sine squared x is actually just 1. Okay, and 1 over cos, so this is 1 over cos x all squared. This is actually secant squared x. Okay, so from here to here, sine squared x plus cos squared x is equal to 1. So maybe I'll just write it down here. The derivative of tan x is secant squared x. Okay, for secant, this is 1 over cosine x. Okay, now we actually have a rule if you want to use this, or you can use the quotient rule again. But it said that, maybe I'll just write it down again. So recall, if you want the derivative of 1 over some function of x, then it's actually negative f prime of x over f of x all squared. Okay, we use that, we prove that rule using the quotient rule in that section. But again, you could just use the quotient rule. Okay, but if we use this rule, then it means that y prime is negative, the derivative of cosine, so negative sine x over cos of x squared. Okay, so that's going to be positive, and I'm going to rewrite it as sine x over cos x times 1 over cos x. So it's actually tan x times secant x. Okay, so the derivative of secant x is tan x secant x. Okay, like I said, you don't need to remember all of these because you can compute them using just the derivatives of sine and cos. Okay, so two more. So secant is 1 over sine x. Okay, so using the rule above, y prime is going to be negative cosine x over sine x squared. So if I rewrite this, oops, it's cos x over sine x times 1 over sine x. So I end up getting negative cotan x times cosecant x as my derivative. Okay, last one. So cotan is cos x over sine x. So we're going to use the quotient rule. So the derivative of the top is negative sine x times the bottom is sine x minus the derivative of the bottom is cos x times the top is also cos x all over the bottom squared. So this gives me negative sine squared x minus cos squared x all over sine squared x. I can factor out a negative, and that's going to be sine squared x plus cos squared x over sine squared x. And we already did this, so this is just a 1 on the top. So sine squared plus cos squared is equal to 1. That was the identity we used earlier. And so this is negative cosecant squared x. Okay, so the derivative of cotan x is negative cosecant squared x. Okay, so those are the derivatives for all the 6 trig functions. You only really need to remember the first 2, sine and cosine. Tan sometimes is useful to remember as well. So, a couple more examples. Okay, so here we're using the product rule. Okay, so this is my u. This is going to be my v. They both have x's. So f prime of x is going to be the derivative of 2x cubed times v as it was, plus the derivative of secant x times 2x cubed as it was. Derivative of 2x cubed is 6x squared times secant x, plus the derivative of secant x is actually secant x tan x, and we're going to multiply that by 2x cubed. Okay, so if you want to factor this a bit, we can take out a 2, an x squared, and a secant x. And I'm left with 3 plus x tan x. Okay, one more. So here we have a quotient rule. So my top, okay, and my bottom. So g prime of x is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, so the derivative of 4 tan x is 4 secant squared x, and the derivative of 7 to the x is 7 to the x times ln of 7 times 4 tan x, and this is all over 7 to the x squared, or 7 to the 2x. I probably want to factor out 7 to the x. Minus 4 ln 7 times tan x all over 7 to the x all squared. So now I can cancel this 7 to the x with one of the ones down there. And our final answer will be 4 secant squared x minus 4 ln 7 times tan x all over 7 to the power x. Okay, and I mean, you could factor out the 4, you can go a bit further, but you could turn everything to sine and coses if you wanted, but this is a fine way to leave your answer.